Today we are going to see how to solve the linear equations with three unknowns by using the determinants. Okay, so see, consider the system of linear equations in three unknowns x, y, z. These are the unknowns, okay, in this equation. Okay, and consider the system of linear equations with three unknowns x, y, z. Okay, so see, first equation a1x plus b1y plus c1z is equal to d1. Okay, so look at here, a1, b1, c1, these are the coefficients of x, coefficients of y and coefficients of z, and this d1 is nothing but constant in this equation. Okay, so in this way we are going to consider the three set of linear equations. Okay, and now we are going to solve this equation by using the determinant. Okay, to solve these equations means we are going to find the value of x, y, z. Okay, so first step, find determinant d. Okay, and this determinant d is obtained by coefficients of unknowns. Okay, so this is the determinant of coefficients of x, y, z. Okay, so see what is the determinant d. So coefficient of x is a1. Okay, so first column is nothing but coefficients of x variable. Okay, a1, a2, a3, these are the coefficients of x variable. Second column of this determinant is nothing but coefficients of y, b1, b2, b3, and third column of this d is coefficients of z, that is c1, c2, c3. In this way, here for three set of equation we got determinant d of order 3 by 3. Okay, now find dx. Now see the suffix here, dx. Okay, how to find dx? Remove first column. What is the first column? First column is nothing but coefficients of x. Remove that column by constant, then we got determinant dx. Okay, so remove that a1, a2, a3, and instead of a1, a2, a3, write down d1, d2, d3. d1, d2, d3 are the constants of the equations. Okay, that is right hand side of this equation. Okay, so once we replace a1, a2, a3 by d1, d2, d3, we got determinant dx. Okay, so remaining elements as it is no change, b1, b2, b3, c1, c2, c3. Okay, similarly find dy. How to find dy? Replace b1, b2, b3, that is coefficient of y, by constant. We got dy. So see what is dy determinant? a1, a2, a3 as it is. Now second column will be changed. Okay, by d1, d2, d3, and third column is c1, c2, c3. Similarly find dz. Now replace third column by constant. So we got dz. First column no change. Second column, that is coefficient of y, no change, and change in third column, that is c1, c2, c3 by d1, d2, d3. Okay, so in this way we find first of all determinant d of coefficient of x, y, z. Now we find dx, dy, dz. Okay, and by Cramer's rule. Okay, this rule is called as Cramer's rule. Okay, so by using this Cramer's rule, value of x is obtained by x variable. Value of x variable is obtained by dx upon d. Value of y variable is dy upon d, and value of z variable is dz upon d. Okay, So in this way we got the value of variables by using Cramer's rule. This rule is called as Cramer's rule, okay? And in this way we find the solution of system of linear equations by using the determinant concept, okay? Now let's see example how to use this method to solve the system of linear equations, okay? So let's see the example. Solve the system of three linear equations with three unknowns x, y, z, okay, by using Cramer's rule or by using determinant, okay. So first of all we will write the equation in proper manner, okay. That means all the variables on left hand side and on right hand side we take the constant, okay. So given equations are x plus y plus z is equal to 3, x minus y plus z is equal to 1, and x plus y minus 2z is equal to 0, okay. Now find determinant d. Firstly we find determinant d. Determinant d is nothing but coefficient of x, y, z variable, okay. So write down first column is nothing but coefficient of x variable 1, 1, 1. Second column is nothing but coefficient of second variable y 1, here minus 1, here 1. Third column coefficient of z 1, 1, minus 2. Okay, solve this determinant, we got the value of determinant d. Okay, how to solve? Take first row 1 into what is the minor of 1? Take first row, first column. Minus 1, 1, 1, minus 2. Minus 1 into this minor of 1. Delete first row, second column. 1, 1, 1, minus 2. Plus this last one into its minor. Delete first row, third column. 1, 1, minus 1. Okay. Solve this. We got minus 1, minus 2 here. 2, minus 1, minus 2, minus 1, plus 1. Minus minus it becomes plus 1. Okay. Cross multiplication and subtraction. So here 1 minus 3 minus plus 3 and plus 2. So what is the value of d? D is equal to 6. Okay. Now find dx. Stop. Now dx. Replace first column by coefficient of x by constant, okay. So what are the coefficient of x? 1, 1, 1, and replace the first column by 3, 1, 0, that is the constant, okay. So what is determinant dx? 3, 1, 0, 1, minus 1, 1, 1, 1, minus 2. Remaining column as it is, no change. Solve the determinant. 3 into what is the minor of 3? Minus 1 into minus 2 plus 2 and minus 1 into 1, here 1. Minus 1 into what is the minor of 1? 1 into minus 2, 1 into 0, 0. Plus 1 into what is the minor of 1? 1 minus 0, 1 minus 0. Okay. Now solve this. 3 to minus 1, 1. 3 into 1, here 3. Minus 2 into minus 1 plus 2. And 1 into 1 plus 1. Okay. So what is dx? Dx is 6. So value of dx, that is determinant dx is 1. Okay. Now find dy. How to find determinant dy? Replace second column by constant. Okay. Remaining two columns as it is, no change. 1, 1, 1. Okay. Second column 3, 1, 0 ne replace करायचा. Third column as it is and solve this. Okay. So now see 1 into what is the minor of 1? Minus 2 minus 0 into 0, 0. Minus 3 into, okay, minor of 3 minus 2 and here minus 1 plus 1 into what is the minor of 1? 0, minus 1. Solve this. Minus 2. Here we got minus 3. Minus 3 into minus 3 plus 9. And here minus 1. Okay. So 9 minus 3. Here we got 6. Therefore, value of dy is 6. And lastly, we find dz. Okay. dz. How to find dz? Replace third column from d by constant. Returning two columns as it is 1, 1, 1, 1 minus 1, 1. And here third column is replaced by constant. Okay, so we got dz. Solve this. 1 into minor of 1, 0, minus 1. Minus 1 into minor of this one, 0, minus 1. Plus 3 into minor of 3. Delete third column, first one. 1 minus 1, that is plus 1. Okay. So now see, minus 1, minus plus 1 and 2. 3 2s are 6. Okay. So now minus 1 plus 1 get cancelled. dz is equal to 6. Okay. So in this way we find the value of four determinants d, dx, dy, dz. Okay. So according to Cramer's rule, therefore by Cramer's rule, x is equal to dx upon d. What is the dx? dx is 6. Value of dx is 6. Put here 6. What is the determinant d? 6. Okay. Therefore, what is the value of x? 6 upon 6? 1. Similarly, what is the value of y? dy upon d. dy is 6 and d is also 6. What is the value of y? 1. Similarly, z is equal to dz upon d. What is dz? 6. d 6. Therefore, what is the value of z? 1. Okay. So, what is the solution of this system? Solution by Cramer's rule is x, y, z. That is 1, 1, 1. Okay. So, in this way, we solve the system of linear equations by using Cramer's rule, or we call it as determinant method. Okay. Thank you.
Like my channel, please like, share and subscribe. Thank you.